go. Hey everybody, happy Tuesday, and welcome to the stream. Hopefully your week is off to a great one so far. For those of you that are in the US that are dealing with the polar vortex and all that crazy weather, please stay warm. Hopefully you're able to stay indoors and all that good stuff. So I am in Texas. We are cold for Texas, I'll say that, but not quite as frigid as some. So Tuesday stream. Last week we did a little bit of work with building a particle libraries registry using Vue and Nuxt, and this week, or today specifically, we're actually going to get back to doing some RC car hacking, which should be good fun. I'm particularly excited about that. So what we're going to do today, and I'll show you a bit of a sneak peek of what's going to be coming here in a little bit. We have, and I shared a bit of a demo this last week, but if you're new, if you're just jumping in, I'll share this with you now. I created a set of RC cars that are mesh networked together. So there's 3 of them. They can all run a demo using mesh publish and subscribe commands. So basically just low latency UDP messaging across the local network. These are running Particle 3rd generation dev boards, and I have soldered jumper wires just right into the PCBs on these little Thunder Tumbler cars from you can get at CVS. The sharper image style Thunder Tumbler cars. So I want to do a little bit more. Right now they're just running a basic demo, and actually I'll show you that demo really quick on the cars that are on the floor. So let me go just to my cars mode here so you can see. So I have these 2 cars on the floor that are connected right now, and I can trigger a demo of those through a gateway device. I have a gateway that's set up. It has a function on there that I can then use to run the demo really quickly. So let me go ahead and do that. They're going to move forward and back and then do a little bit of a spin around. So go forward, back, and they do a little dance for me. That's exciting stuff. So that demo is just pre-arranged. Let me switch back to those demos right now are sort of pre-arranged. That's the standard. It's just I've predefined a sequence. That's all it is. So today I want to actually add some swarmbot behaviors. I want to do some more interesting, more fun kind of stuff. So what I want to do today is take this. I'm going to create sort of leader-follower behavior. So instead of just a predefined set of actions that each car takes, move forward, move back, turn right, turn left, I'm going to have a leader car that is going to be, excuse me, my leader car is actually going to be controlled by the remote control, and then it's actually going to emit commands to the follower cars to have them come along. So only one of the cars is going to be remote controlled. The other are going to sort of do what they're told based on the commands that come along. So that's our plan today. We're going to talk through some of the existing code and then sort of modify it from there. So should be pretty exciting. Thank you to C# Fritz, to Jeff for the host. If you're not following C# Fritz, please do so. See how to get this command to work. So please follow Jeff. Does awesome stuff. He's building Stream Deck extensions, which is really awesome, but he really does a lot of stuff in Visual Studio Code, C#, all over the place. So definitely check him out. Appreciate that, Jeff. All right. So here's what we're going to do first. I'm actually going to walk you through. Let's do a little bit of code window. And let's do my actual code window.
Just that moment with you, just
noticing that some of these scene changes in OBS are kind of a pain. Okay. The existing demo, like I mentioned, is pretty basic. I've set a couple of different speeds that represent analog voltages that are set against the car. So for turning, forward, back, and for delaying for forward, back, and turning. I'm setting the pin modes of each of those as outputs, setting them all to low, and then the real important piece of the demo is just calling a go forward function, go back, turn left and right. The way that those look is it's just analog right. So because these are these pins can accept voltage pulses that then determine how fast the wheels turn. I'm just doing an analog right of the speed value to go forward, of my speed value to go back, and then same thing with turning left and right. So what makes the difference here at the end is the cars go sort of slowly forward, slowly back, and then spin very quickly, is that my speed value for turning is 255, whereas the speed for just moving forward and back is 85. So that's what causes the wheels turn so fast that the tumbler is sort of designed to go up on its top wheel and then spin around. So that's part of the fun there. So we need to modify this, and I have created, I have a GitHub repo. Let me change. Hey, Joe. Welcome, welcome. So I am going to show you, I have a GitHub repo here for the project, and let me add this in stream. If that works. Twitch Loft, thank you for the follow. I appreciate it. Appreciate it very much. Here, let me do this. Volume's kind of low. Okay. On the music or just my mic? Let me know if that's any better. All right. Almost halfway to Cyan Brandon. Yes, that's right. In fact, I will put that in the here. So if you're interested in what Cyan Brandon actually is, just put it in Stream Elements. If I get 100 followers on Twitch by March 1st, I will dye my hair cyan blue. Very, very exciting stuff. Joe, let me know if the volume is any better. I appreciate it. The other thing that I wanted to share, this is the source. I just put it in chat for the RC Cars project, so that's under Particles GitHub repo. And there's really several things that I want to do that are kind of under development. Where we are right now is demo mode works. And then from here, I want to work on creating the Swarm RC powered leader. So like we talked about, having sort of the leader car and then a couple of follower cars. I don't think there's anything I need to do different to the gateway in this case. So I haven't shown it specifically. There's 3 RC cars in this mesh network, and there's the 4th device, that gateway device, that actually is cloud connected, because everything here is going to happen on the local network. I'm not actually going to create that controller, at least not yet anyway, but I'm going to create sort of Swarm leader and Swarm follower projects. So I'm going to do that here inside of my VS Code project. But first, I am going to, let's see, code, shut it down, because I want to create 2 different projects here. What did I call them? I'll get there. Eno files. Is that Arduino files? Yeah, so the particle devices accept .eno files. They also accept .cpp files, so you can create your own. You can create Arduino style files, and the cloud compiler will handle all of the appropriate includes, all the right header files that are needed for .eno files. But I can also just call these .cpp files if I want to. There's a few things that vary in that case. If I'm going to make these .cpp files, I have to make sure I've got forward declarations for all of my methods and functions and things like that. But yeah, you can definitely use either. So I have showed off the Visual Studio Code extension before. I'm going to use it again. I'm going to open a Shift Command P, and I'm going to create a new project. So please open a folder is the command or the message that I got here. I'm going to open a folder, not in there. It's under Particle, under RC Mesh. I'm going to open that folder. And what are we going to call this one? We're going to call this one RC Swarm Leader. How's my audio? Is it a little bit better for the folks that are listening? I know that Joe, you'd mentioned it's a little bit low. Let me know how it's going. RC Swarm Leader. Create that there. Perfect. It's going to initialize that project. And I'm using a multi-root workspace, so I'm going to come in and do a little bit of fiddling around here in a moment in order to get this to do what I want it to do. But that'll create me an RC Swarm Leader.eno file that has setup and loop and all that good fun. So Shift Command P again. And create new project. I will open another folder. And same root folder, and we're going to call this one RC Swarm Follower. Okay. Okay, so now that that is done, I am going to close this down and do a bit of a cheat here. Because there is a code workspace file. Get this actually properly in the screen. There's a code workspace file here at the root that has all of the other two existing projects, and I want to add one for my leader and follower here as well. So leader, this is a one-time kind of thing that I will create in order to have my multi-root workspace open up with the Particle Workbench extension intelligence so that I can compile against individual projects. So RC Mesh follower. Boom. Okay, I'm going to shut that down. Sound from the mic is a bit low. Music is very low. I feel like every time I got to readjust this. All right. Thank you, Twitchloff. Let me know if this is any better or I have to start yelling. Good fun. All right. So, got that. Hello. Hey, Mohit. Welcome. Welcome. Okay. So I'm opening this up again. I'm going to open the workspace. Yes, open workspace. And now I will have all four of my projects here ready. Thank you, Twitch Off. Okay, much better. I appreciate the real-time feedback very, very much. David says, is that the real Mohit or just a super fan? That's gotta be the real deal. Trunksy, thanks for coming. Thanks for joining, and I appreciate the question. You ever worked with C? Yes, yeah, definitely. However, maybe not in the context that you're asking. I'm trying to learn a GUI, was recommended GTK Plus, so hard to find good documentation vids. In fact, for C overall, I find it hard to find good sources, although I did manage to find good sources for C itself. Other than that, or no, it feels like nobody's using C anymore. I wouldn't say that's true. I think that in the world of embedded development, C is still quite prevalent, C and C++. One of the things that I wasted a few years back on GTK Plus, I'll never get those back. Yeah, I kind of cringed a little bit at the read, so for sure. I have never used C for GUI development. I've done Java for GUI development. I've done C# and the Microsoft toolchain for GUI development. I've done a lot of web work, but never C for anything outside of embedded. And even in the embedded side, most of the compiler toolchains now use the GCC style compilers. So it's C, but the target on embedded systems tends to be C, but it's also a lot of C++ language features are supported and usable as well. So, all right. What is that exclamation mark? Cannot resolve workspace folder. Did I make a mistake? I always make mistakes when other people are watching. Let me open this again. Thought I did the right thing. RC mesh vehicle, RC mesh. Oh! Yep. Swarm. That's right. Slightly different. Svetomir, hey man, thank you for the follow. I hope that you are doing well, friend. I think actually that makes user number 50, which is halfway to Brandon turning his hair blue. I just actually referred to myself in the third person. All right. Shameful to speak about myself in such ways. All right. Coming up. All right, folders resolved properly this time, and I will open the workspace and everything should be hunky-dory. Hello. All right. Close my README. So here we are at this point. I have the projects. So C is used mainly for operations heavy on CPU, and everything else is done elsewhere. That is a question that I don't know the answer to. Cyan is better than magenta. I mean, in the eye, it depends. Eye of the beholder. I mean, I think on my complexion, my fair complexion, cyan probably would be a little bit better. You are indeed correct. So in this repo as well, I have a project. It's kind of like I did last week with the libraries repo, and I've created a couple of different created a few different issues here, for things that I'm going to work on here. And so let's actually make this first commit here, because I did finish number 2 here. So added swarm projects, closes number 2. And we push sync. I don't know. We should end up using a terminal for that. Okay, and so now what I want to do is add role variables for role variable and function to each car. What did I mean by that? Trying to think right now what in the world I was thinking. I don't think that's necessary. I think that's a sort of a Yagni moment that I just had for myself there. I don't need to mess with that. I do, however, want to focus on this next piece, which is, so ultimately the way that this is going to work, fingers crossed, in theory, is that I am going to read, when I use this trusted remote control on the first car, I am going to read the voltage on the pins on the Xenon that I have already wired to. And then I am going to send a mesh publish message with that voltage, with that pin, and we're going to go from there. So we'll see how it goes. Let's actually start with, close this down. See an RV mesh vehicle. I'm gonna keep open my vehicle code just as reference, but let's actually, so this is for the leader code specifically. What the leader is going to do is set up, get rid of all this boilerplate. Get rid of that boilerplate. Yeah, leave that. Deal with that later. So the key pieces of this are, I'm actually going to change the pin mode. What I was doing before on these vehicles, and so I have the same pin mappings here. I'll just actually pull this over so that I have it, so I sort of know my connections. A0 on the Xenon is left wheel back, A1 left wheel forward, right wheel forward and back on A2 and A3, and they share a ground. So the first thing that I am going to do is set my pin mode, and my pin modes this time is going to be an input instead of output. So I'll be that copy and paste developer right now. I'm going to change these to, let's see. Oh, remember that keyboard command. Let's type it correctly. So I'm going to set all of those to inputs now, and ultimately what I'm going to do now on each loop through is I'm going to do a digital read on the pin. Sorry, I just had a random thought. I'm wondering if I'm going to have to debounce these. I'll think about that in a second. No, I shouldn't. I'm going to do an analog read, and then I'm going to basically just turn around and send a mesh publish for each of those. But I also want to do a serial on that too, so I can actually see what's going. Well, that's not going to work because I'm not connected. All right, well, let's just go through in the loop and let's do an analog read on one of these. Just try with one, see how it goes. So analog read. I'm going to use the snippets. Maybe. So, analog read of a left reverse. All right. And then I'm going to be reading this a lot, and if the value hasn't changed, let's do this. Oh yeah, back to your comment, Trunksky. Yeah, Twitchloff is right. Most GUIs nowadays are definitely written with HTML, CSS, and JavaScript. Even a lot of desktop GUIs, honestly, using a shell like Electron. Definitely be worth checking out. So last left val. Right. So if left val is not equal to last left val. So if I'm getting a 0 on here, or if the value hasn't changed, I'm not going to do anything. I'm just going to make sure that this actually hasn't changed. But if the value has changed, then I will set last left val to left val. Good fun. And then here's the fun part. I will do a mesh publish. Mesh publish. In my event, this is what I have to think about. What I'm going to read on the other side. I can call this left. Oh, this is left reverse. Last left. Just call it left R. Fix myself here. Mm-hmm. Okay. And then I think I'm just gonna do. Yeah, I'll just do that. Just send in the actual value, so we'll publish that each time. And then I will also, since we're in sort of debug mode right now, I'm not going to turn the cars on just yet. I will go to, I'll do a particle publish and actually send that value as well. Okay. Now, if everything is happy here, so I'm going to configure this workspace for my device. First thing I'm going to do is I'm going to make sure I know which device I'm actually working with here. This is my leader. So oh, now I remember why I wanted to do the leader and follower thing. Still doesn't matter. All right. Yeah. Let me add that. I won't do it right now. So it is RC Mesh 1. Let me go into my networks since they're all on the same network. And my RC Mesh. There we go. It works again. The real purpose of the stream today was to show off Particle's really awesome 404 page, if you haven't seen it here, and to ask a very important question: would you rather fight a shark with bear arms or a bear with sharks for arms? So, weigh in. I'd love to hear what y'all think. All right, never mind that. It's RC Mesh 1. I know that's the one that I'm looking for, or at least I think that's the one. Yes, that's the one that I'm looking for. RC Mesh 1. What is happening? Okay. You web people like myself. The definition of insanity is doing the same thing over and over again and expecting a different result, and yet here we are. I'm gonna go ahead and flash it, and because I know that it's RC Mesh 1. So configure workspace for device. So I'm gonna choose my swarm leader, and this is gonna be RC27 of the device OS. The target platform is Xenon, and RC Mesh 01. Hit enter. So I am now configured, and I'm going to do a cloud flash, excuse me. I can flash locally as well. I don't have this device is not serial connected at the moment. I'm actually going to switch scenes too so that you can see. Let's see here. So just go into the leader mode. There we go. All right, so now I want to choose my, let's see, save that. And failing that, let's see here. Left R val. I'm gonna get my plan B. Oh yeah. Cloud flash. Let's seeing. Here, let me go back. I'm going to flash the swarm leader. And it's going to try and... Oh, yeah, it's not online. Let me actually plug it in. Okay. Preparing. It's trying. Going to do its thing. This may take a second. So while that is doing that, so can you run this particle mesh thing on a normal Arduino? So, great question, Twitchloff. So the distinction that I would make here is that particle devices are very similar to Arduino devices in the sense that they use wiring, C, they can work with all of the same libraries and a similar tool chain. One of the differences is that particle devices have sort of for free out of the box a device OS set of APIs. So in addition to your user firmware, there's a whole device OS toolchain that runs on the devices that handles things like what I've showed off with particle publish and mesh publish, excuse me, for local network messaging. It is also the sort of the vehicle behind using device cloud variables and functions and really getting access to information. Let me get the console actually open again. So secure cloud communication, all of this kind of stuff that comes along for the ride is part of using the particle devices. So you can use particle devices, or all this particle mesh up works with particle devices, and they're very similar to programming Arduino. So an out-of-the-box Arduino, no, that doesn't work with the toolchain sort of as it's set up today. You have a very similar experience in actually programming them. All right. So I got good news here. I got my last handshake just a minute ago. So I'm going to go ahead and try to compile now. And then I can turn on my remote control here in a moment. I failed to flash. Come on, come on. Oh, that's the wrong one. What am I getting the logs here? Device is not discoverable or is offline. Oh, I just picked the wrong one. It's RC Mesh 03. Go back to configure workspace for device. Swarm leader, Xenon, RC Mesh 01. I think the other ones are offline anyway. Okay, configuration done. Now we can flash. So the other thing I'm doing, Twitchloff, is I'm actually doing an over-the-air firmware update. So I don't have any of these devices actually serial connected to my computer. I can do that. I absolutely can program locally, install the tool chains locally, do all that stuff. The important thing here, the distinction I'm doing here, because these devices are connected, they're in sort of a, not inaccessible, just sort of a small example in my small office, but they are not connected, and yet I can still flash them because it uses their network connection, in this case via the gateway that has Wi-Fi, to flash those. What in the hell? Let's see, so if I want to build a local particle mesh network at home, I would need to buy some particle microcontrollers. Yeah, definitely. And feel free to, you can send me a message if you're interested. I can provide a few recommendations, maybe even offer some guidance and places to look. All right, what am I doing? All right, I gotta see what I'm doing wrong here. No, silly. I think I need to do the same thing here that I did with the other one. Maybe. My brain is failing me right now. Let's try this again. If this works, that's a big if. And the update, the flash actually starts happening, I will start to see some things stream across here. Flashing. Oh, failed. You know what? You failed. You failed. Failed to do what I wanted. No, we're gonna do it again. Okay. Started. Well, that's good. I just got a straight up failed last time. Maybe. I'm looking at my device and it seems to be doing what I want. Actually, it seems to have gone completely offline. Let's see. It's not doing anything. It's just offline. Why? Tiny LiPo battery. Okay. Battery switch time. So bear with me. I'm gonna do that real quick. Okay, happy again. Do the devices have any custom RF protocols for short-range inter-device communication? Great question. So all of the, and it's online, so I'm gonna go ahead and reflash while I'm answering this. Come on. There we go, Cloud Flash. No. Cloud Flash, Swarm Leader. Okay. Yes. So all of these new device or these third generation devices. So the Xenon are the devices we're looking at today. They're mesh only. The Argon is Wi-Fi, Boron, cellular, and all of those devices also implement OpenThread and use the the latest Nordic NRF 52840 chip, which has 802.15.4 mesh networking with OpenThread. So they all implement the OpenThread stack. They build the network that's created as an OpenThread compatible network, and all of the messaging that I'm doing here. So this mesh publish is actually UDP based multicast messaging. So it's going to be super, super low latency. And the reason why the demo that I shared earlier of the car sort of moving back and forth works is because it uses, it's using UDP under the covers, so the messages go across very quickly. I missed that to see if it actually, power down came on. Is it still failing on me? Hold on. I'm in the right place. Prepping to flash. RC Mesh 01. Should be the one that I have on my desk. And yet, here, I'm going to add this too so that I know it's actually happening. I was messing with things the other day. I've added a version publish message and a function so that I knew what was actually happening. Because this keeps on telling me that everything is working. I'm getting the log. Okay. I think what I am tempted to do right now is actually go back to, let me go back to code. Go back to split screen mode. Cool, we'll check out this open thread. Been a while since I looked into home automation protocols. I was involved in developing the KNX RF multi protocol, if you know that one. That one is not, it kind of rings a bell. I'm gonna have to make a note of that to research later. Cool. So I keep getting these flash failed statuses. So I know it's online. These things that just work so smoothly until you start trying to demo them live. Let me go back and configure, start over configuring again. I'm configuring my swarm leader folder to do RC27080, Xenon, and RC Mesh 01. That's my device. Okay. Save this. P. Cloud Flash. Cross your fingers. I have a backup plan of USB cables that I will make work. But I may have to go into like be right back mode for just a moment. All right, it says it's flashing. Flashing started. Come on. I want it more than started. I want it to actually complete. If you see my, it's actually flashing magenta now, which is, or doing something magenta. That's a good news, a good sign. Magenta on that LED means that good things are happening. It's just taking its time. Right. Taking its sweet time. What is going on? All right. I'm going to restart this. It goes offline. I'm going to wait for it to come back on. So you're seeing some, oh, you're not seeing anything. You're about to. I reset the device, so I'm getting some diagnostic info. It is back online. Hopefully back online. And now I'm going to attempt to Cloud Flash again. If you came here to watch me flail about, welcome. Welcome. Happy to have you. Once I get this working and we can get a nice... Okay, so it's telling me success. That should be a wonderful thing. I should start... Man. Okay. So we're getting some garbage values. I may have to think about how to clean that up. You noticed, if you look here, there actually were some particle publish values that came along for analog 303. Doesn't really mean much of anything. However, assuming that I was correct to do this, when I turn on the remote, and it's now on, and I start, this is left reverse, right? I should see a message that comes up. Because it's continually doing a read, right? So if you, let me go back over to my cars. I am holding down the button. Let me turn this to the side so you can kind of see what's happening here. Raise this up a bit. Oh yeah, wrong side. So that side, that wheel is actually moving backwards. But I am not getting anything. I wonder if I programmed the wrong pin. Okay. Let's think about this here. Pin modes as inputs. Should just be reading those. I wonder if I'm going to get reset this and see what happens. There's a very strong possibility that this is all just a dumb idea and that I'm not actually going to be able to read those voltage changes, even though they are actually happening. Did I reset it? Still reconnecting. Dun, dun. I may bail on this idea and just go to orchestrating the local movements, right? Which is totally okay. I can absolutely do that. So what I can actually do in here instead, so let's try something a little bit different while I see if I can get my brain wrapped around what the heck is going on. I'm going to add a particle function. Hold on. Let me go back into... There we go. I'm going to add a particle function. And it is going to be... We're going to call it forward. And it is going to call... I'm cheating on this one because I'm going to pull my go forward out of here. And we'll use that here in a second. But particle function forward, go forward. We'll do another particle function. Just use the snippets, Brandon. Just use the snippets. Back. Correct. And stop. Let's call this one all off. So these are going to be available on my leader device and will send commands to the follower devices, basically. So this will help me sort of build out some of the functionality. So I'm not going to have... comment this out for now. Yeah, okay. Device is it's taking a little bit to come back online, so I don't know what's going on there. So RC car online, send that. We're going to set my version here, 0.8. And then I'm going to define functions for each of these forward, back, and all off. I actually have these here a little bit that I can pull out. I'm going to change their functionality. So in the last sketch, in the last bit of firmware, what these functions did was, as it sounded, they turned on or off the wheels by setting voltages on the pins. I'm going to do something a little bit different here. And we're actually just going to fire those messages, and it's going to command the cars on the floor, not the car on the desk here. In fact, let me switch my scene here to be... Stick with that. And the weird stuff. Okay. And all off, instead of doing the analog right, is going to do what I shared earlier, which is just do a mesh publish. Right. And it doesn't need to send a payload. It'll just be null. The car will figure out what to do. And that's what ultimately all of these are going to do. They're just going to do mesh publishes. Just remove that code. No point in keeping it. Oh, I have to get the right function. Hold on. And these also need to return something. This one's stop. And it's going to call all off. It's the helper, so that can be called internally as well. Okay. And go back. We'll return the same. My loop won't need to do anything. I'm just sort of waiting for those commands. This will do a mesh publish of all off. This one will do a mesh publish of go forward. And then this one will do a mesh publish, go back. So now my sequence is effectively that the leader can determine where the followers go, and it just sends those commands via mesh publish and subscribe. So I will, I'm gonna put this, flash this to the device really quick. I was having a hard time connecting. Good fun. Love that. Okay. My leader Xenon is being finicky and is not connecting to the device cloud, so I may have to find a different way to flash it. Just a second. Okay. It is blinking orange, and I can't remember what that means. So I'm gonna look it up. In the data sheet? No, that's the charge status. I'm trying to find the right keyword to trigger what I have seen a million different times, and I'm trying to remember exactly what it is. I know what that is. It's giving me nothing? Really? Ugh. All right, I'm gonna power this device down and bring it back on. This is driving me up the wall. Where's that table flip GIF when you need it? Because that's what I need right now. And I wonder if this is all caused by the as he trails off. I wonder if this is all caused by my silly idea to set those as inputs and do an analog read. Maybe I messed myself up. So I unplugged those jumper wires and no, still no good. Well, crap. let's write the code on the follower side and see what we got. So basically, and this is effectively the same way that it would work if I was actually reading those pins from the remote control, whether the sequences are predefined or they're coming from this remote controller. I am sending mesh published values and then reading them on the other side. So I'm going to open up my follower sketch. Pull in the same definitions here. And not worry about the pin modes, but I will set these values, set the string value. Let's modify this a little bit. Let's say swarm leader online for this one. And then for these, and here I need to go back to actually setting my inputs properly, as I did here. So I set my pin modes to outputs and digital write all of those to low so that they're ready to go. This car is going to actually actuate the motors. And then I'm going to say swarm follower online. I think that's good for now. So then we're going to do a bunch of mesh publish messages. So let's just start with one. Mesh publish, excuse me, mesh subscribe. Mesh subscribe. What did we call it? Forward. Oh, wait, what? Oh yeah, the functions. Yeah, mesh publish, these are set. Go forward. Go back. Right. And same as I did before, I'm going to steal the same code here. We'll clean this up and just take it as is. Ah, we gotta take the whole thing. Do go forward. So I'm going to turn all my I don't have to do all off. I'll save that for now. I need my speed values as before, although I could set those. Those could be set. That would be another enhancement for later. Set the speed value on the follower here. Just a second. So when it gets a go forward command, it will go forward. So let's we set up this one to configure for device. I'm gonna make this I'm gonna configure my follower. It's gonna be RC27, also Xenon, and this will be RC Mesh 02. So this will change the behavior on 02. Down there, over there. Save, and let's cloud flash that one. Let's go over here, and I have done something horribly wrong to 01, I think. Not for Photon. Bad configuration, bad configuration. Configure workspace, follower, 27, Xenon, RC Mesh 02. Okay. Configured. Let's try a cloud flash on that one. We've got RC Mesh 02 open, to follower. Oh. Yeah. Oh, I'm an idiot. The particle functions mesh subscribe, and particle subscribe need a similar payload. It's not payload. Function signature, which is what what? Oh, what is wrong with me? Okay, let's just do mesh subscribe handler. Yep. Go forward. Cool. There we go. There we go. Now we can flash. Follower. Looking back to see if O2 starts flashing magenta. Should see something in the console here as well. We're gonna find out. Taking forever today. I wonder if maybe I need to restart my gateway. Considering it, I just might go do it. Yeah, what am I getting on the logs? If the log is telling me it timed out, okay. Gateway timeout. All right. I'll restart my gateway. I am cautiously optimistic. Hey, what do you know? Gateway problem. My problem. So I just needed to actually get this thing, get the gateway restarted. So I think I'm back in business. Let's go back to split screen here. So device number 2 is online. So we'll go ahead and flash the follower. I'm just going to do go forward for just for now. testing, I'm going to just go forward for a second. So do a cloud flash, the follower. So it should go to number 2. You'll see above me on the screen there. And once again, the GitHub for this mess is now and will be here. Just posted that in the chat. Flash. Come on, come on, come on. Failed to flash. Let's figure out why. Gateway timeout again. Yeah. I know that gateway timeout is not my gateway. Oh. We may be back online now. Okay. I think that may have actually worked. Yep. Yeah, swarm follower right there. Okay. Yay! All right. So now let's get back to the leader and do this again. Oh, yeah. Same here. Particle functions need to return an int. Right. So I'm going to flash this one. This is my leader. So I'm going to go back to his page, or his tab. RC. Okay. So I may end up, it's a bummer, I don't want to do this, but I may have to can the stream a bit early. Because it looks like all right, here's what I'm going to do. I'm not going away. I am, however, going to go into be right back mode because I need to pull out some extra long. I need to do some USB cable trickery so that I can do some local compilation here and flashing of my RC car here. So bear with me. I will be back in 3 minutes. Okay. I'm back. I have now, so let me show you. What is this one? Right. So I'm pull myself out of the way here. So I'm going to show you just the car now. Yeah, let's do this for a few moments. Move it back. All right, so you see the fancy USB cable that is now connected to my car. So that is where we're at. So I'm just gonna program this using alternative method. I'm not going to use the cloud compiler. I am going to do the more traditional. And OBS is killing me today too. OBS is absolutely killing me. Serial identify. So I'm gonna just make sure that this one here is connected. So I have the two Xenons connected. Should be this one. Timed out. To put it very quickly in listening mode, I'll run that again. Make sure I got the right one. Should be that one. Time out on me again. I have another Xenon on here that's connected to another project, which is why it's reading multiple. Particle, serial, identify. There we go. Okay. 76F7, that's not it. 7. Devices, RC Mesh 1. That's the one that I want. Okay, so now I know I've got the right one connected. And I am going to now compile my leader a little bit differently. So what I'm going to do in this case is, instead of doing cloud compile, I'm going to do particle flash application local. That's the option that I'm going to choose. But in order to flash that way, I need to actually put this one here, put this device in DFU mode, or device firmware update. So I'm going to do that real quick. That's done. So now I'm going to click on Flash Application. We're going to use RC Swarm Leader. And it's going to start doing its thing. So I'm going to get status info here as it goes and does its thing. So when you do a flash from the cloud compiler, you don't have to install a local toolchain. You don't have to do any of that stuff yourself. Error. What's my error? Go forward, go back, stop. Stop, go. Oh, yeah. Silly copy paste error. So many. Copy paste errors. My gosh. So the function signature for particle functions returns an int, and then it takes a string of arguments. You have to make sure you have those. or things do not compile, which is probably the source of all my frustrations. What we got now? Same? Seriously? Function. It helps if you put things in the right places, Brandon. Just more copy and paste without paying attention. So let's give this the eye test. And go forward, go back. I'll have the right signature. My loop has nothing. Great. Flash. Muted. So, great. Now it looks like everything is good to go. I'm connected back to the Particle Device Cloud. And I can verify that by going in here. It's connected, Swarm Leader V08. And I should have my functions here to do things forward, back, stop, go. Great. So, if everything works here, via local compilation, I should now be able to click on this function. Clicking forward will publish, mesh publish, go forward, and my follower will see that command to go forward. It'll go forward for a second and then stop. Assuming that I have done everything correctly, cross your hands, cross your fingers, and let's go back to, let's go, I'm gonna move this. It'll have to do. I was not planning on local compilation today. So we'll do this very quickly. See what happens. So I'm going to click on the forward button in code. It's still going. So there you go. So that worked. Great. Still going. It's still going. And of course it was still going because I didn't stop it. I just go forward and then delay for 1,000 seconds. So that's nice, Brandon. It's not gonna do anything for you. So let's actually fix this now and go back. Let's implement the all off function here in my swarm follower. Let me pull. Here's what I'm going to do. I'm going to We'll pull this webcam in here and flip it. Seeing the sausage being made right now. What? Oh man. It's ridiculous. Right. Just gonna make this kind of small so you can see what's happening. Only one of these cars is really going to do anything. But I'll keep that right up there. So you can continue to see what's happening as I flail about. All right, so now when I click on forward, this shouldn't change. It should stop after a second, and then I can bring it back. So let's implement back while we're at it. So I'm going to do a mesh subscribe for go back. Let's just do mesh subscribe handler for go back. And we'll call this one go back. As I said. And pull from here. This just sets what's happening right now. Same thing, delay for 1,000 milliseconds, and all off. Great. Cool. So I have get back all off, so I can now flash, cloud flash in this case, of my follower. And that will be on RC Mesh 02. And while I am waiting on that, let's actually have the leader. No, actually, the leader's already doing what it's supposed to do. I've already published that message. Right? Yeah, forward, back. Okay. So I can have it come back when it's done. And then if this works, simple forward back. We're gonna keep it kind of sane for now. We're gonna do forward and back with the two cars here in a second. And then if that works, I will add my leader here who's on the desk and we'll go forward and back. And we'll end it there. Let's see if that actually worked. RC Mesh 02, when was this? 314. I don't know if that flashed, so let me try that again. The thing that I really like about having these multi-root workspaces in Visual Studio Code and the Particle Workbench extension is these kinds of scenarios where I'm creating firmware across devices that needs to interact, but there's different projects for each piece of firmware. So that works out pretty well. Okay. I still haven't gotten a notification that anything happened here, so I'm wondering if I'm going to have to resort to doing the same thing and just flashing locally. Or flashing using DFU mode on my desk. Which I could do. Now that I cannibalized one of the webcams, let me try this again. Because it says it's working. Preparing to flash. Okay. Okay. Come on, do thing. That's taking too long. Something is up. So I'm gonna go grab the device. Oh wait, device failed. Yes. Thank you for telling me that. I know that it failed. All right, we're gonna do it locally, DFU. So I have this. Got it on my desk. Just going to connect the USB cable here. I'm going to put it into device firmware update mode, which on particle devices means the LED is flashing yellow like that. You just hold down both buttons, let go of the reset button, and then wait till it starts flashing yellow, and then you're good to go. And now at this point, again, I can go back in and I can do a local flash. Shift Command P. Do flash application local. I can choose my swarm follower, and it'll pull up the task and do the whole thing in DFU mode. Woo! So much stuff. And it is blinking cyan, which means it is, oh, now breathing cyan. Okay, and you'll notice in my in the console above me, it's back online. So, yay, that's great. I'm gonna put it back on the floor and we'll run this again. Okay. So now, when I hit forward, it should go forward for just 1 second, and then I should be able to hit back to claim it back to me. So let's do that. Yeah, and then within the frame too. And now back. Kind of back where it was. Good. Okay. One car. We have one car working. 20 minutes left to go in this stream. Today's stream, the theme of today's stream has been adjustment, changing approaches mid-flight, building the airplane while in the air. So I am now going to flash the other car, and I'm going to go grab it, and we're going to do the same thing. We're not going to try cloud flashing. We're going to do it locally. So same deal here. I'm going to plug in the USB cable. I'm going to put this Xenon into DFU mode. And I'm going to run Shift Command P to open up the command palette, and I'm going to flash the application locally. Choose RC Swarm Follower. Now this will be number 3, RC Mesh 03. So let me go into that one real quick. Flash it before it's loaded. All right, so I want to see some happy event logs come across here. All right, follower mode. It's good to go. So I'm going to unplug, put this back on the floor, and we'll see what happens. Okay. So now in my leader firmware, when I do forward and back, both of the cars should move, and then both of them should come back. So demo number 2. And back. I'm not frozen, I'm just waiting. All right. No, you called it. You called forward and back. You did it. Okay. We're having fun today. Final piece in the last 20 minutes that we have. What I want to do now is, my leader car is just sitting here on a stand, not moving, not doing anything. Because all I have done for the code for it is when I call go forward, go back, it just does the mesh publish, mesh subscribe. Mesh publish to go forward, go back, right? So I want to implement the same logic here for going forward and back. Thank you, Svetomir. I appreciate it. Thank you so much. It's made my day. Those applause. I was looking earlier today about doing like animated GIFs in stream, like on the overlay, and I still got to figure out exactly how to do that because I want one of those like highest of 5s for these kinds of situations. I mentioned the table flip earlier. I have a table flip GIF as well that I plan to use a lot. So we are nearly there. What we're going to do now is actually have the leader replicate the same functionality as the followers. Its real difference is that it is emitting those commands to the other devices, but it has to do both. It has to actually go forward and back and emit those commands. So when I call go forward, I wanted to actually do this. Let's do this. For my leader, I want there to also be a I'm gonna have to come and clean this up later. This is going to need to have a different signature. Oh yeah, and it needs to have a speed variable also. Okay. It's going to need to have a speed variable, excuse me, and let's just call this forward, save myself some time. So now with forward, I'm going to call the mesh publish to go forward. Shouldn't really make a difference where I call it. And then for the follower, I'm going to go back. I'm going to pull that in here. I'll call this one back. Does not need that. Nothing. So forward and back. And then I do need an all off that works the same as my followers. So instead of this all off, I'm going to change this one to off. Terrible, terrible function naming. This needs to be cleaned up. Oh my gosh, awful. And I'll clean it up off stream. Right now, my goal, my purpose in life, my reason for being is to make sure this works. So these are calling the local offs. Go back. Okay. There's no reason really for a delay there. Okay. So let me local compile this before I bother hooking it up to make sure that it actually works. And we're doing swarm leader. Wall of text is good news. Yeah. So when I'm doing a local compile, this is ultimately what I'm looking for, something like this. The GCC compiler did actually create something for me. Wonderful. So with that done, let's flash it. I have the leader on my desk now. I'm going to set it into DFU mode. Ooh. DFU mode. What is happening here? Okay. And flash application local. This is my leader. So let's flash that and maybe get some nice info when this comes back online. It's reconnecting now. Blinking, blinking, blinking. Still blinking, blinking, blinking. Okay. And it's online. Great. So now that my leader here is online, I'm going to go put it down on the floor in front of the other two and rearrange some things. And then we will run this last demo, see how it works. Fingers crossed. Okay. Leaders in the front, followers in the back, and we are ready to run this. So again, the way that this should work is the leader does its movement, but also publishes a message to the followers to do the same. So it is the device that's controlling the actions of all the others on the network. So forward. All right, well, the leader is sending I know what I did. Table flip GIF. Set these pins to outputs. Ah, so annoyed. I thought of everything. All right, I'm gonna compile that locally. Then we're gonna try again. That's for the leader. One moment. Plugging it back in. Putting the device back into DFU mode. And we're going to flash locally. Leader. Should get some more info as it comes online. 351. Good news. It's back online. Okay, let's try this again. Let's try it again. Okay. Seriously this time. Fingers crossed. I'm gonna hit the button while I'm crossing my fingers. What's happening? Okay. So a little bit of a delay. Not terrible though. I don't know if I should. And then back should do the reverse. Probably need to tweak this a little bit. Slow, slow, slow. Okay. Something's up, something's up. Oh, this would be a lot easier if I didn't have to pick that thing up every time and reflash. So I'm going to publish the go forward message. Oh, did I forget to call back? I did. Man, got Twitch brain today. So, compile again. We're gonna reflash the leader one more time. Here we go. Okay, so what did I change this time? I actually implemented back, which I forgot to do before. When go back, when the function is called. And then I changed the mesh publish message for forward to happen first. We should do the same thing here. Before it goes back. Publish the message briefly. All right. So now let's flash to the leader. Okay, it's coming back online. Okay. On the floor, one more time. Maybe try to also set those a little bit apart so they don't run into each other. So now, fingers crossed, forward. You're taking far longer than usual today. So we might have to pick this up in the next stream. I'm looking at particle status earlier, and it looks like there's actually some Bill, okay. Intermittent errors with certain types of compile requests, although I wonder if that's actually affecting some of this as well. Device is online. All right. Came back online 3:55. I did flash it. Okay. Last time, I'm going to try back real quick. Yeah. Okay. So the back worked. They went together. They are doing their thing a little bit. Ah, that looks so much better. Yay, it's working back. Forward. See, sometimes you just have to keep pressing buttons. I don't know why. All right. So that's where we are at this point, and I'll bring this document back up because I think ultimately this is where I want to go, and I'll share. We'll do more of this on Thursday. I'll share a little bit of a recap. This is where we are now, is creating this swarm-powered leader. I do want to pick back up the RC car piece that I was messing with, the RC piece that I was messing with earlier, of actually kind of controlling this actually works on the main car a little bit right now. But I need to figure out what's going on there and why that got borked on me at the beginning of the stream. So I'll share a little bit of an update about that on Thursday. And then there's some other ideas I have in here on swarm, sequences with range detection. This is all in the repo, and I will push this out here in just a second. In fact, let me just go ahead and commit right now. Let's see, did a bunch of stuff on the stream. Does it work? Kinda. All right. Commit. Push, sync, push, whatever. Excuse me. So there's a lot more that I want to do. I will share more about that in the next couple of days, and that is it for me now. But there's a few folks left. I actually want to drop into another streamer who is a very cool guy, and drop into. So we're going to raid Robert Tables. This guy does a bunch of stuff with Docker and containers otherwise. So let's actually drop into his stream and hang out. But thank you all so much for hanging out today. and for spending some time walking through RC car stuff. We'll do this again on Thursday. So have a great day, and talk to you later.